Alright, for practical 6, the last question is we're trying to create a program to guess the square root of number. So if you look at if we give you the value is 169, you can guess the square root is 13, right? What if you didn't know it was 13? So you need to find a way to actually guess it step by step. So the solution is given, alright? So we would say that first we declare the value that we're going to find the square root of. So we're going to find the square root of 169. Then we have to have a starting guess. Of course, if your starting guess was 13 square, we know it is 169. But what if we didn't know the answer was 13? So our starting guess, start a very small number. Okay, we start at 0.169. How do we get 0.169? The value that we are trying to guess the square root of, we divide it by 1000. So 169 divided 1000 is 0.169. Alright, so we said that the 0.169 is a starting solution or starting guess. So how do we use this starting guess? Okay, so first thing we do is, in order, let's say if we know that 0.169 is the possible square root, right? We need to square it. Okay, we need to square it. Okay, we can square. You can see it being squared. All right, we square. If 0.169 you square it, you get 0.0286. Okay, now we need to find the difference between this and the actual answer. Okay, so the actual answer is 169. So 0.0286 minus 169. So you can see here. So the possible guess or the possible solution, okay, multiply itself. Remember that the first time the solution is actually the increment, and the increment is actually 169 divided 1000, 0.169. So we square the 0.169 and we minus it from the value. The value is actually 169. So the difference is negative 168,971. Okay, however, we don't have to worry about the negative because we use FABS. FABS stands for floating point absolute value. That means we just take the magnitude. Okay, the reason why we use FABS instead of ABS is because the data types of solution and value is a floating point. Okay, it's a double precision value. Okay, so now we repeat the loop until the error or the difference between the guess and the value. Okay, we find the difference, right? So the difference right now, what is the difference? Is 168,971. It's a very big difference, right? If the difference is 0, that means we already arrive at the guess, right? But we are saying that the difference must within 1% of the value. So what is 1% of the value? 1% of the value is basically value divided 100. So it's 1.69. So 1.69 is 1% of 169. Okay? The difference, the error difference, that means the error. So let's say you have a guess. Guess is a solution times solution. So let's say your guess was 13. So let's say solution is 13. 13 times 13, 169, right? So 169 minus value is 0. Of course, 0 is much smaller than 1%, right? Is 0 smaller than 1.69? It's true, it's smaller. So therefore, this loop condition becomes so. As long as the error is bigger than 1%, this loop will continue repeating and repeating itself. So every time it will guess, it will increment the guess by 0.169. So for the next round of calculation, the possible solution, the solution that we looked at is 0.338. Okay, 0.338. Okay, 0.338. Let's see what is the difference. Okay, what is the difference of 0.338? You can see it from the actual coding here. So for the next run, 0.338. Okay, this is the next round. How do you get 0.68? The first starting guess was 0.169. Okay, we increase it by 0.169. That means the next guess is 0.169 plus 0.169. Okay, next, if you square 0.338, we get 0.114. Okay, and what is the difference between the actual value? It's basically 169 minus 0.114 is 168 885. Alright. In the next round, if you take 0.338 and you add it up, see when you next round, every time you repeat the loop, right? What do you do? You see this this is very important. Every time you repeat the loop, if you just want to know what's the long form for this is, it's very simple. It's basically solution plus increment. And do you know what's the definition of the increment? The increment is basically 0.169 every time the value divide 1000. So every time you up the value of the guess, because you're systematically guessing, okay? You're systematically guessing what is the square root. So the next time your guess goes up, and do you see the difference? Does the difference get smaller or bigger? Okay, the difference actually gets smaller. So every time you run the equation, the difference gets smaller and smaller and smaller, and we stop the difference. We stop getting the solution until it is at least 1% of the solution. So we can go on continuing to the end. All right, you can see towards the end. All right, towards the end we can see. All right. See the second last, see the difference is 4. Okay, 4 is actually higher, bigger than the 1%. 1%, remember 1% of 169 is 1.69. So 4 is definitely higher. On the next iteration, okay, we found the guess is 1301. Oh, it's very close. We know the answer is 13, right? So 1301 square, we get 16933. It's actually bigger than the value we want. But the difference is 0.3381. So when the difference is 0.3381, we find that this condition becomes false. Remember, what is 1% of 169? Is actually 1.69. So you can see here when it reaches 0.33, okay, 0.33. So this, okay. So this becomes false, when it becomes 0.33, because are you sure 0.33 is bigger than 1? So it becomes false. So it becomes false. What happens is this condition stops, and when it stops, we know we got the final solution, which is 13.013. So some of you might be answering, how come it's 13.01? Shouldn't it be 13? Basically, we cannot use this solution. Is not a perfect solution. We can only get the solution within 1% of the actual answer. So we know the actual square root of 169 is 13. But when we use this program, we only can get within 1% of the solution. You see, and the condition becomes false. Okay, condition becomes false when the difference is less than 1.69. So you can see the condition. They ask the condition: is it true the difference of 0.338 is bigger than 1.69? Of course it's not true. So it's false. So you see on this, so it stops. Okay, we reach within 1% of the solution. So the idea is, you see the difference, or the error. In this case we call it difference. It's the error. Error means is the distance, or difference is the difference between our guess and the actual value. So our first guess, remember, is the first guess is actually 0.169. Okay, 0.169 is our first guess. So 0.169, you square it, you get 0.026286. And then you minus it from the actual value we are looking for. The actual value is 169, right? So you minus it. So you see 168971 is the distance to the solution. Of course, if the difference was 0, we got the solution, correct? But the distance is so high. So the difference is 168971. When the next round is, we keep on adding 0.169. Okay, so 0.338, you add 0.169, you get 0.507. Okay, and you keep on adding 0.169. And every time you keep on adding, you see the difference gets smaller. Do you notice that? The difference to the answer gets smaller. So 168, okay, the difference 166, 165, 164, 163. The idea is that the difference will keep on growing smaller until it is 1% of the value. And the difference here you see is 0.33. This is less than 1.69, which is the, you can see here, this is the condition when the loop becomes false, when the difference is less than 1%. Okay, in this case the difference becomes, you can see on the last iteration, the difference becomes 0.33, and of course 0.33 is smaller than 1% of the 1% of 169, which is 1.69. So the condition becomes false, and this is the final solution. Okay, final solution is 1301. Okay, all right, basically that's it. Okay, if you got any questions about it, send me an email. Okay, the idea of this problem is to just guess the square root of a number. Okay, and the loop repeats until the difference between your guess and the value is less than 1%. Okay, within 1% of the value.